assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, we're being asked to find what frequency a speaker diaphragm will be moving at when the magnitude of acceleration will be greater than that of gravity. So in order to work through this problem, we are told that the amplitude of the speaker, the maximum amplitude of the speaker, is 1 micrometer, which is equivalent to 1 times 10 to the negative 6 meters. We are going to want to put it into meters, especially since we'll be working with gravity, which is meters per second squared. And so we're trying to figure out when A is going to be greater than G. And gravity is in itself, we want to remember that gravity is 9.8 meters per second squared. So we know that we are looking for when our acceleration is going to be equal to gravity. And we also have our acceleration equation where acceleration equals omega squared times amplitude. And so since we want when acceleration is going to be equal to gravity, we can actually take this equation and make it equal to 9.8. But before we go plugging numbers in, let's go ahead and just finalize what equation we want to use. We're trying to find frequency, so using omega does not necessarily make sense, but we can alternate this and change the term because omega actually equals 2 pi f. So since omega equals 2 pi f, we can actually rearrange this equation to have it be acceleration equals 2 pi f squared times xm. And again, we know that we want it to be equal to gravity, so we can actually just make that equal to gravity. Since it is equal, we can ignore the acceleration term, and we can change our equation now to 2 pi f squared times xm equals gravity. And we're trying to solve for frequencies, so we want to rearrange our equation so that we are actually solving for frequencies. So the first thing we would do is divide both sides by xm, so we would end up with 2 pi f squared equals gravity divided by amplitude. And then, of course, we would want to take the square root of both of those, so we would end up with 2 pi f equals the square root of gravity divided by amplitude. And then, finally, we would end up with frequency equals the square root of gravity divided by amplitude divided by 2 pi. Now we can actually plug our known values into this equation. And if we look back up here, we see that we know that our amplitude is going to be this 1.00 times 10 to the negative 6 meters, and then our gravity is our 9.8 meters squared. So substituting those two values in, we have frequency equals the square root of 9.8 divided by 1.00 times 10 to the negative 6 divided by 2 pi. And we end up with an answer of frequency equals 498 hertz. So this is the answer to part A of the question. What is the frequency when A is going to be equal to G? Now part B of this problem is asking for greater frequencies, is the acceleration going to be greater or less than G? So for this, let's just look at our equation. If our equation is g equals 2 pi f squared times acceleration, the relationship here means that if we increase f, if we take this term and make it larger, then obviously this whole term is also going to increase in size, which is going to end up making it greater than the acceleration of gravity.